Hello, everyone. My name is Ivan, and I'm the co-founder of Polycode. And for the past 6 to 7 years, we have been developing various blockchain SDKs, front-ends, smart contracts, dApps, tokenization platforms. My colleagues have written a book on blockchain development. And for the past 6 to 7 years, we have seen many different trends come and go, many different user experience improvements, as well as developer experience improvements. There are still many things that need to be addressed before blockchain achieves mass adoption, and before it gets integrated into the existing infrastructure. But before I get into what exactly needs to be addressed, I just want to take a quick peek at this. So the user is interacting with the banking application, which then is interacting with the banking backend. This is extremely simplified diagram. But the point being that the users are interacting with their assets, moving assets across different banks. This all happens seamlessly, fluidly. Banking backends are built differently, different stacks, different infrastructure. Everything is different, yet everything is interoperable, everything works. The user only cares about his asset. Everything is done safe, and it works. It's seamless. So when we compare that to using assets in blockchain, you're interacting with your wallets, you're interacting with dApps, and you have to take care of which smart contract am I interacting with which asset am I interacting with, is my RPC set up properly, which chain I'm interacting with, et cetera, et cetera. So there are these layers of complexities, and right now we're interacting with the bare architecture of the system. This has clearly been done under the premise of security, decentralization, asset ownership, et cetera. But I argue we can maintain that while increasing interoperability. Right now, the way this works is actually really, it puts the digital asset market in a state of deadlock. There are very few assets coming in. If one exists on chain, are tied to a certain L1, L2 chain. And the biggest issue here is that the asset is tied to a chain. That is, the chain has the monopoly over the asset. When we compare that to the banking example, the asset is free to move across different databases. So this is a really big issue for us. And clearly, you have to expose yourself to these bridges and other unacceptable risk factors if you want to move the asset across. There will be an increasing number of chains and chains and assets in the future. There will be app-specific chains, different block sizes, finalities, etc. I mean, Sergey covers a bunch of these things. And this is just going to continue these issues of cross-chain communication, fragmentation, liquidity fragmentation, etc. So that's why we built Cluster, which is a stack on top of CCIP. Cluster is composed of three main components: sovereign assets, adapters, as well as gateway. And there's this one component which we call Cluster Handshake, which is essentially just a CCIP two-way communication. Because right now CCIP is one-way communication, and we need to know whether the transaction succeeded or not. So we created a Cluster Handshake. But let's speak about the sovereign asset first. So the sovereign asset that I mentioned earlier, that it doesn't exist yet, in the model that we're using in DeFi today, this sovereign asset exists natively on any chain, meaning that their cryptographic fingerprint is the same on each individual chain. Meaning that, for example, you have USDC deployed on so many chains, bridged USC, whatever, every contract address is different. This is just a complete mess for user experience as well as developer experience. This doesn't work. But the worst thing is that these assets are tied to this chain. So with the sovereign asset model that we have already built, these assets exist like above the chain. They are no longer tied to a specific chain, yet the chain acts as a custody, as a custodial for this asset. So kind of like what we had in the beginning when I described the traditional model of moving dollars and euros across different banks. So this is just a database that saves the asset. So these sovereign assets add also another layer of security because they have the same address on each individual chain using create2 opcode, but we can get into that privately if you contact our team, and we can go fully into that. I don't have much time here. So the chain no longer has the monopoly over the asset, which is paramount. Then we have these adapters that we have built, which are standardized templates for supporting multi-chain asset, meaning that the existing protocols that exist in DeFi now are not supporting multi-chain cross-chain activity. And with these adapters, we can basically take these multi-chain assets, swap them on different chains. We can do so many things, defragment liquidity. For example, case in point, we have used this code to make a multi-chain swap from on chain A. We transferred the asset on chain B, swapped it for asset B, and bridged it back, all in one transaction, because the asset was sovereign and the protocol had this adapter around it. Protocol that I'm describing is Uniswap. Then we have Gateway. Essentially, to boil it down to a point, Gateway allows you to leverage CCIP to the next level. It allows you to handle insane amount of assets on many chains that are coming along. So basically, right now, if you want to handle an asset on in a multisig on Ethereum, you have to deploy the multisig on Ethereum. Then if you want to do it for Optimism, you have to do it again and again and again and again. This just doesn't work. So we made it so that you can send a transaction on one chain and it executes on any chain you'd like. So basically, this makes asset management a lot easier. And if we compare it to, for example, these banking applications that will have dozens of chains, dozens of banking apps, dozens of banking chains, that is, they don't want to have basically a multisig on each individual chain, then sign it on each individual chain. It just doesn't make sense. So you sign it on your source chain, and the message is propagated through CCIP. The logic is handled by our singleton contracts, and the whole thing just works flawlessly, basically bringing the traditional infrastructure closer to blockchain. We think this is the major improvement in asset management in blockchain. So basically, building on top of CCIP, we are trying to hide the complexities right now. Whoops, what's this? We are trying to hide the complexities right now. It's not that easy for a Web2 developer to use CCIP. And in our work, we have interacted with dozens of small-scale businesses as well as enterprise clients. And we have seen that their developers are simply not familiar with even what a private key is, things like that. They're really familiar with simple TypeScript things, etc. So we are trying to hide these complexities by adding additional smart contracts of our own, which are described here as the cluster singleton contracts, as well as adding an SDK on top of that. This is clearly all relayed by CCIP, and we are simplifying everything. So the cluster handshake that I described earlier really is a two-way communication, ensuring that the source chain can detect whether the transaction was executed on the destination chain or not. This is extremely important because this is the way we preserve atomic composability. So if you have, let's say, you say, take this asset, move it to a different chain, then swap it, then stake it, and take the NFT you get out of it and bring it back to the source chain. So you can do that with our stack in one transaction, clearly supported by CCIP. And this whole thing happens seamlessly. If any of the events along the way fail, the entire thing is reverted into its initial state. And we think this is extremely important. So CCIP right now is a one-way communication, but it has to be both ways. And I was actually speaking to a banker 2 nights ago, and he was describing this complex risk management system they have in the Swift network. And he said that this is a major improvement because with CCIP it's easy to send a message, but you need the communication. The communication has to be both ways. So this is a really big deal. This is just a simple diagram showing a part of our stack, how we handle these singleton contracts that basically relay the message and then either acknowledge or don't acknowledge where this transaction has happened on the destination chain. So, no, it's not working again. There you go. Now I went too far. So, let me just go to this. Oh, conclusion. Great. So, can we take a couple of steps back? Yeah? Yeah, it's not really working. So we have these. Can we go one front? Yeah. Thanks. So the use cases for this. So we have these sovereign multi-chain assets that can be deployed on multiple chains. This is also important for compliance. Maybe you have this banking chain, you don't want your asset to be on Binance Smart Chain for whatever reason, and so you can just choose not to use that chain. Like on the smart contract level, you forbid it to be there. This can help defragment liquidity across networks. This is just regular stuff that Sergey talks about, but we can actually, with Cluster, we can actually make it tangible right now already. What I mentioned earlier, the single multi-sig wallet that can control assets across different blockchains. I mean, we're having issues in our team with the safe. Just removing one signer on one chain doesn't remove it on other chains. It's just that the overhead is just unnecessarily big. And with CCIP and our stack, we have simplified this. Also, DAO cross-chain actions, something that has been discussed by Sergey as well. So use case in action. We're working with one of the biggest exchanges in Southeast Europe. They currently basically take your crypto and liquidate it for fiat. Simple as that. But they're really having user experience issues because someone is sending the USDC on the wrong network, and then they have to bridge it, and just the whole thing is just a mess. And then something that gets sent to the wrong address on the wrong chain. The whole thing just doesn't work. So with these sovereign assets, they can you can settle a transaction on any chain. I can basically settle a transaction on Optimism. It will be liquidated for fiat seamlessly, extremely fast, and the whole thing runs smoothly. And they are having issues with this, right? Because if you send them USDC on, let's say, AVAX, and they don't have liquidity there, they have to bridge it, and then they are exposing themselves to a risk that is actually not acceptable. Also, they're a regulated exchange. This is something that they are really not allowed to do on a certain level, like playing with the user funds like that. So with the sovereign asset model, right now with them, we are working on it. And this has been a really successful proof of concept. This is still young, and the state of DeFi is still really focused on the way things exist at the moment. But in the future, USDC will not have that many addresses on that many chains. It will be really just like a dollar, like it is now. They can move anywhere seamlessly and easily. This is just a quick example because I didn't have the time to put in the demo of deploying these assets, interacting with them, bridging them. This is all super simple. And with our SDK, you can make this so it's programmable, right? So it's not like you don't do it through a front end, you can do it through a back end. There are these example of signing transaction, but I have 2 more minutes, so we didn't have the time for that. You can reach out and we can do the demo for you happily. So to conclude, users right now are mostly interacting with the bare architecture of the system, and this is simply not scalable. Last speaker said, or 2 speakers ago, he said, don't you want your grandma to pay the groceries with MetaMask? And actually, I don't. No, I don't. She's going to mess it up, and she's going to, it's just a complete mess. It just doesn't work that way. So the users are interacting with the bare architecture, and this is not scalable. This has been done, as I said earlier, under the idea that we need to preserve decentralization, ownership, and security, and I argue that we can still maintain that. I mean, I've been in the crypto space since 2013. I'm a full believer of decentralization, but this is just not scalable at the moment. So with the adoption of CCIP and our stack cluster built on top of CCIP, we believe that developers can finally build apps that allow users to use assets and apps instead of wallets and blockchains. Thank you very much.